The fate of our universe lies in the hands of the unknown. The unknown of matters and energies that exist within our universe. The unknowns of dark matter and dark energy who seem to play the strings of our existence. So, how do we know what our universe will become? The answer is, we don't know. But before we come to any crazy conclusion like the dark holes will destroy the whole universe, let's see what theories have been made regarding the future of our universe, and dig deeper on these mysterious factors that play such a huge role.
This theory suggests that the universe, if it's slowing down, will create so much energy that it will collapse upon itself and maybe causing another Big Bang. Maybe our universe is like a heartbeat, expanding and then contracting to further keep the health of the known universe. The second theory thinks that the universe will keep expanding, to where the heat around the universe will be even distributed, causing energy to be unusable in the universe, and causing us all to freeze. Will the whole universe come to a standstill, and the remains of us just frozen, similar to the fate of those who froze in the Ice Age? Lastly, this theory argues that the universe will expand exponentially to where everything will move faster than the speed of light, creating so much distance and speed from galaxies and stars from each other that they won't appear in our night sky, splitting all known matter, even to the atom. Our future so far doesn't look so bright, and that's because dark matter and energy make up most of the universe, yet so little is known about it. And although nothing, and I mean nothing, is known about dark energy, we do know a little bit about dark matter. So let's explore this, and see if we can shed some light on this matter. Space, according to Einstein, is not empty, so if there's another matter in the universe that exists that we cannot see, it must act similar to normal matter, but it doesn't reflect, emit, or absorb light. Let's take water for example. Water is like dark matter. Technically we cannot see it, but it's still there. And we can also see the normal particles floating around in the water. This brings up another question though. If we can't see it, how can we prove it exists? So, we know dark matter is like normal matter, or baryonic matter in other words, is a physical substance that inhibits mass within our universe. Except, unlike normal matter, it doesn't interact with light. So the question is, how do we prove it exists? Well, let's take a look at an unusual phenomenon. When an object orbits a sun or a star, the closer it is to the sun or star, the faster it goes, right? Just like how a spiral spins or how satellites orbit our Earth. Now, don't you think it would also affect galaxies the same way? Surprisingly, it doesn't. Masses orbiting in galaxies find themselves moving at constant speeds, regardless away from the distance of the center. Weird, right? That must mean that another gravitational force, from a mass that we cannot see, is also affecting the paths of these galaxies. Let's take a look at our water example again. When we add a force to water, it affects the movement of the other particles. It makes it spin. And it's like dark matter in a way. Dark matter already has its own force, which is its gravity. But its gravity affects the normal matter, and effects of how they work within our universe. Ugh. My brain hurts. It's time for a pop quiz. How much do you think normal matter makes up the universe? You're right, it's only 5%. Normal matter, which is the ground we stand on, the seats you sit on, to the stars we see at night, is all made of normal matter. Yet, only 25% is dark matter. That's a lot of dark matter. That probably means that dark matter affects the universe a lot more than we think it does. Let's explore that. Since the Big Bang, the start of our universe, we know that the universe has been expanding, or growing. And as of today, we know it's still expanding. But recent studies of distant solar systems and stars have shown us that the universe isn't just expanding, it's expanding exponentially. Sound familiar? This ties in with our third theory that the universe will be expanding exponentially, increasing in speed and distance. But does that really mean that we will all be torn apart? Unfortunately, and maybe luckily, we'll never know for sure. And what we found out so far, it sounds pretty plausible. But we'll never get our answer even from the millions of years from now. But it's really interesting to think of how our universe works. And all the kind of options, what we can become and what the universe will become. Yet, the universe will still remain a mystery. But I think it's our job to find out.